From launch to successful booster catch and splashdown in the ocean, Starship showcased exceptional performance across the board during its 5th integrated flight test. Let's do a complete breakdown of the mission. SpaceX kicked off the final round of pre-launch preparations on October 11th with a stacking of Ship 30 atop Booster 12 after installing flight termination system charges. The FAA granted SpaceX the license for Flight 4 on Saturday, October 12, confirming that the company met all safety and licensing requirements for this test flight. Once licensed, teams finalized system checks and conducted pre-launch verifications in preparation for launch day. On October 13, an hour and 15 minutes before liftoff, the flight director conducted a go-no-go poll and gave commands for propellant loading. Within 50 minutes, 4,600 tons of liquid oxygen and methane were pumped into the vehicle. At T-19 minutes, the Raptor engines began chill down to condition them for ignition. The vehicle then went into internal power, and the onboard computer took over the countdown sequence. At T-10 seconds, the deluge system began flowing water under the launch mount. The Raptor startup sequence began at the T-3 second mark, followed by engine ignition. When all 33 booster engines reached the required thrust level, the vehicle lifted off from a launch pad. The sight of the rocket clearing the launch pad was nothing short of surreal, with all engines performing nominally during the liftoff and ascent phases. The vehicle passed through maximum aerodynamic pressure 62 seconds after liftoff, a key milestone that tests the rocket's structural integrity. The thermal protection system tiles on the ship appeared to withstand the vibrations of the flight. Around 2 minutes and 33 seconds into the flight, the booster's outer engines shut down as planned, leaving only the center 3 engines burning. Shortly after, Ship 30 ignited all 6 engines and smoothly separated from the booster stage. After a quick flip maneuver, Booster 12 successfully reignited its center 10 engines for boost backburn and began its journey back to Earth. At around the 3-minute and 30-second mark, booster engines shut down and the boost backburn concluded. The hot stage ring was jettisoned next to reduce the overall mass of the booster. Future booster iterations will feature an integrated lightweight hot stage ring that will not need to be jettisoned. Once sole vehicle and pad systems were confirmed ready and the necessary health checks on both the booster and the tower were completed, the flight director issued the manual command for the booster to return to the launch site for the catch. 6 minutes and 31 seconds into the mission, the booster initiated its landing burn. 13 inner engines ignited flawlessly, guiding the booster back toward the launch tower. As planned, the center 10 engines shut down, while the remaining 3 engines carefully steered the booster into the waiting tower arms. The booster touched down gently onto the tower arms, with the landing rail system absorbing the landing impact as it compressed. The booster was captured nearly at the center of the arms, with alignment closely matching the plan specifications and showing no significant deviations. During the landing burn, a fire was observed at the booster's aft section, which persisted even after the catch, but it didn't interfere with the landing process. The fire was later attributed to damage sustained by one of the booster chines during the descent. Elon Musk later confirmed that, in addition to this, some outer engine nozzles were slightly warped due to intense heat and aerodynamic forces. This damage was evident as debris fell from the engines after the booster catch, highlighting the extent of the nozzle degradation. Following the successful catch, SpaceX teams immediately initiated the safing procedures for the booster, ensuring it was secured post-mission. While the booster was being carted, Ship 30 continued its flight into orbit. 8 minutes into the mission, the ship shut down its engines and entered a coasting phase around Earth. Nearly 45 minutes into the flight, Ship 30 began re-entering Earth's atmosphere. As the ship descended, it experienced intense heating from atmospheric friction, causing plasma to form around it. The onboard cameras captured stunning visuals of the plasma flow, broadcasted via Starlink satellites. As Ship 30 descended into the denser layers of Earth's atmosphere, the frictional heating increased significantly, causing damage to its forward flaps similar to the issues seen with Ship 29 during Flight 4. However, the damage was less severe this time around, thanks to the improvements made to the flaps and thermal protection tiles. The control software adapted to the situation, and all 4 flaps were able to stabilize and slow down the ship as it descended through the atmosphere. The thermal protection system tiles were subjected to extreme heating as they turned red hot during re-entry. Remarkably, the tiles remained firmly attached throughout re-entry, enduring intense heat and successfully protecting the ship's structure as it returned to Earth. At the 65-minute mark, Ship 30 ignited its engines for the landing burn and executed the flip maneuver. The ship then splashed down in the Indian Ocean, achieving its final objective. Moments after splashdown, the vehicle exploded as expected. Since this was an expendable test flight, recovery was not planned. Elon Musk confirmed on X that the mission was successful, stating that Starship achieved its primary objectives of performing a booster catch and executing a successful splashdown. In addition to these primary objectives, SpaceX utilized the mission to evaluate several critical upgrades implemented on both the Starship and the booster following insights gained from Flight 4. One notable enhancement was the testing of the newly designed thermal protection system tiles installed on the ship. The live stream commentator provided insights into the innovative heat tile tests conducted during the flight.
Additional tests on this one today, where we left off some missing tiles again to test some additional backup layers. We also have silvery looking tiles on Starship as well. Those were pretty much standard tiles, but they were wrapped in aluminum. Aluminum starts to melt at roughly the same temperature where steel starts to lose its strength. If we see stuff melting, we know what our steel is going to be exposed to. But
NASA Administrator Bill Nelson congratulated SpaceX on the success of Flight 5, emphasizing its importance for NASA's future lunar missions under the Artemis program and potential crewed missions to Mars. This flight test was a significant milestone in SpaceX's journey towards a fully reusable spacecraft. Achieving both the return and landing of the booster at the launch pad is crucial to SpaceX's long-term vision of rapid reflight. The company envisions a future where a landed booster can be quickly prepared for its next mission, potentially within days or even hours. With a few more successful splashdowns of the Starship upper stage, SpaceX aims to catch the ship using the launch tower arms, mirroring the booster catch success. In the coming days, SpaceX will share more details about the Flight 5 mission, including what went well and what didn't as they look at the data. Be sure to keep an eye on our channel for updates and news. A day before the launch, the FAA released an updated re-evaluation of the final programmatic environmental assessment for the SpaceX Starship program at Boca Chica. This document highlights the FAA's investigation into key safety concerns raised about SpaceX's operations at Starbase. The main issues addressed include the deluge system water quality, the impact of the hot stage during splashdown on marine life, sonic booms from returning super heavy boosters, and potential effects on local wildlife from launch operations. After an extensive review, the FAA concluded that existing environmental assessments remain valid, and a new or supplemental environmental impact statement isn't necessary. The agency stated that the deluge system can operate under regulatory frameworks without significantly affecting water quality or public health. The FAA noted that the sonic boom zone now extends further than previously assessed, but these impacts remain manageable within current operational protocols. Regarding the hot stage ring, the new splashdown location could be as close as 1 kilometer from the shore, though it is typically expected to land 3 to 4 kilometers away. The FAA confirmed that SpaceX's operations wouldn't significantly impact the environment, including local wildlife and ecosystems, provided that mitigation measures are implemented. SpaceX must continuously monitor environmental conditions, particularly water quality and wildlife health, to ensure compliance with regulations. They are also required to maintain communication with environmental agencies to address any concerns about wildlife or habitat disturbances. In summary, while there are potential impacts from SpaceX's operations at Boca Chica, the FAA's findings indicate that these risks can be effectively managed through proper regulations and corrective actions. This allows SpaceX to continue its operations while still prioritizing environmental protection. Notably, the evaluation document and the FAA Flight 5 license supports SpaceX's ability to conduct multiple launches annually, permitting up to 5 flights per year under the Flight 5 profile. Now, let's discuss the latest updates from the world of science and technology. China marked a major achievement in its space program with the successful retrieval of the Shijian-19 satellite, marking the nation's first reusable and retrievable satellite mission. Launched on September 27 from the Jiuquan Satellite Launch Center atop a Long March 2D rocket, the satellite carried scientific payloads from 5 countries, including Thailand and Pakistan. Once in space, Shijian-19 reached a stable orbit at an altitude of 322 by 339 kilometers, with an inclination of 41.6 degrees. Developed by the China Academy of Space Technology, the satellite weighed around 3,500 kilograms and was equipped with advanced heat tiles for protection during re-entry. During its 2-week mission in space, Shijian-19 conducted a series of experiments, including plant breeding, microbial research, as well as technology verification for new autonomous systems. The plant breeding experiments aim to expose seeds to space conditions, such as microgravity and cosmic radiation, to induce genetic mutations that could help develop crops that are more resilient, produce higher yields, and better adapt to extreme environmental conditions. Microbial experiments, on the other hand, studied how certain microorganisms respond to space conditions, providing insights into biological processes relevant to both agriculture and biotechnology. On October 10, Shijian-19 successfully re-entered Earth's atmosphere, enduring significant heating from atmospheric friction. Thanks to its advanced thermal protection system, the satellite survived re-entry and safely landed at the Dongfeng landing site near Jiuquan. Recovery teams quickly retrieved the satellite and transported it to research facilities for detailed analysis. The findings from this mission are expected to inform future agricultural practices in China and contribute to ongoing research into space-based crop production. The FAA has granted SpaceX authorization to resume Falcon 9 flights following an investigation into an upper stage anomaly that occurred during the Crew 9 mission on September 28. During the Crew 9 astronaut mission to the ISS, SpaceX reported that the Falcon 9's upper stage experienced an nominal deorbit burn, failing to perform the maneuver as expected. This malfunction led to the upper stage re-entering Earth's atmosphere outside the designated safety zone, east of New Zealand in the South Pacific Ocean. Although the rocket stage safely splashed down without causing any harm or damage, the incident raised safety concerns over potential debris and risks to populated areas. In response to this incident, the rocket was grounded, and SpaceX conducted a thorough investigation, submitting its findings to the FAA on October 4. Following the review, on October 11, the FAA granted SpaceX clearance to recommence Falcon 9 launches, stating that the agency accepted SpaceX's corrective measures. However, neither the FAA nor SpaceX has disclosed any specific details regarding the issue or the corrective steps taken to address it. Interestingly, while the Crew 9 anomaly investigation was still ongoing, the FAA permitted SpaceX to launch the European Space Agency's Hera mission on October 7. This decision was made because the upper stage of the Falcon 9 would not re-enter Earth's atmosphere as it was propelling Hera on an Earth escape trajectory. SpaceX has not yet announced when it will conduct its next Falcon 9 flight. However, preparations are underway for the Falcon Heavy launch of NASA's Europa Clipper mission, targeting a launch as early as October 14. This mission will explore Jupiter's moon Europa, which is believed to have subsurface oceans, potentially harboring conditions suitable for life. Thank you for tuning in for the latest science news and Starship updates. If you enjoyed this video, please hit the like button, leave a comment, and share it with your friends. Also, don't forget to subscribe to the channel and turn on notifications so you never miss an episode.